Now that we know how to evaluate a piecewise function, we have to look at how to graph these things. Now, when we graph these things, really, you're just pulling in what you already know about how to graph a linear function, how to graph a quadratic function, how to graph an absolute value function. You now know how to graph all these functions. We just have to put it together. And mainly when we do piecewise functions, we're going to focus a lot on the linear functions. So as we go through this, I'm definitely going to remind you how to graph a linear function. Now, if you're doing this at home, you better have a pencil and you better have an eraser because we're going to be erasing things, we're going to be adding things. So do this lightly, make sure you have a pencil and make sure you have an eraser. First thing I'm going to look at. I'm going to look at this part of the function that we have to graph. It's negative x minus 4, which means it is a linear function. So we're going to be doing y equals mx plus b. Now, m we've already gone over is the slope, and b is the y-intercept. And I'm going to ignore that for just a minute, and I'm just going to try to graph negative x minus 4. So if I have a minus 4, that's telling me my y-intercept is negative 4. So I'm going to go down here and I'm going to put a dot. Then my slope is going to be negative 1. And remember, slope is rise over run. So I'm going to rise 1, run 1, rise 1, run 1. And notice when I run, I'm running in the negative direction. So I'm going positive, negative, positive, negative, positive, negative, which gives me a negative slope of 1. And then I'm going to draw my line. Now that I have my line, I'm going to go back and I'm going to consider this part over here that I had crossed out and said that I was going to ignore. So this says that this line only exists when x is less than 0. Okay, well, x is 0 right here. And less than 0 would mean on the left side of the graph, which means now I have to erase anything over here. And then I have to consider, okay, well, that kind of runs into it right there. Should that be an open dot or a closed dot? Well, it says less than. It doesn't say less than or equal to. So less than would mean an open dot. So I actually have to go erase just a little bit more. And then when I actually come to that dot, I have to make sure that I make it a nice open dot and there's no confusion. Take a look at your dot, make sure it is clearly open. Okay, now we're going to move on to our second one. X, y equals x. If you're graphing y equals x, that's really y equals x plus 0. Which means you're going to have a y-intercept at 0. Then your slope is just 1, so up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then my graph is going to look like that. It's also going to go like this, but then I have to go consider my boundary. My boundary over here says x, this graph only exists when x is greater than or equal to 0. Well, greater than means on the right. So now I have to go back and I have to erase anything that I had on the left side of this graph is gone. And then I also have to consider, well, when it hits the boundary at 0, should it be open or closed? Well, it says equal to, which means this one is going to be a closed dot, and there's your piecewise function. Now, domain. Let me grab my highlighter. Just like before, domain is all of your x values from left to right. So if I start on the left, I'm highlighting, I'm on the blue graph, I'm highlighting, I'm touching, I'm touching the whole way out to negative infinity because of that arrow. Touching. Am I touching when I'm right there on the y-axis? And the answer is yes. I'm not touching the blue part, but I am touching the red part. So I am touching something of the graph, and then touching, 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 and then the whole way out to infinity. So my domain, all real numbers. Range. Let me go get my highlighter. Okay, low to high. If I go low, am I touching, 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 touching? Am I touching anything down here? No. So for our range, we kind of start here at, I'm thinking, -4. Now the question is do you actually touch at -4? And the answer is no, because if you look really closely at -4, that's an open dot. So we get really, really close to -4, but we don't touch it. Okay, keep that in mind. Then we go up. Yep, we're touching the blue graph, touching the blue graph, touching the blue graph, touching the blue graph, touching both the blue and the red graph, touching, 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 and then we've got arrows that point up, so our range goes up to infinity. That tells me that my range is going to be -4 to infinity. But do you remember that conversation we had about the -4 and how there's an open circle here? So this time we're not going to put a bracket on the -4. We're going to put a parenthesis because we get really, really close to that -4, but we don't actually touch it because it's an open dot. Next example, I'm going to move a little bit faster. This is letter C. P of x equals x minus 2 when x is less than 0, and 4x when x is greater than or equal to 0. So once again, I'm going to start with this function. My y-intercept is -2. I'm going to put a dot on -2. My slope is 1. So I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1, and then I'm going to draw a line. Then I'm going to go consider my boundary when x is less than 0. Less than means to the left, so I have to erase. Oh, I'm so sorry. I want to keep the less than. I want to erase anything larger than that, so I'm going to erase that side of my graph. Here's 0. That's your boundary. So one of these is probably going to exist on the left, and one of these is probably going to exist on the right. Then I'm going to go take a look, and this says less than. It does not say equal to, so when I'm considering that dot right there, I'm going to erase just a little bit more because I have to get a nice open circle because it's not touching at that point. Next one, 4x. Again, y-intercept 4x plus 0, so my y-intercept is 0. If I put my 4 over 1, that's rise 4, run 1. Rise 1, 2, 3, 4, run 1. Then I would draw my line, but I already know that x has to be greater than 0, so I'm only going to draw that half. If you draw the whole thing, that's fine. But then you have to go back and you have to erase the left side. It says that it's equal to, so we're going to use a closed dot, and then that's our function. Domain, just like before, left to right. If I start kind of at the middle, this line is going to take me the whole way left, so -infinity. I'm going to come up to the break. It's going to be filled in. I'm going to go the whole way right, all real numbers. Range, low to high. And once again, I'm going to get out my highlighter for this because I think something funny is going to happen. Now, low, I'm going to start here. I'm going to go down, down, down. I've got the blue, I've got the blue, I've got the blue. That arrow is going to take me to -infinity. So my range starts at -infinity. Now, I'm coming up, I'm touching, I'm touching, I'm touching. Am I touching at -2? Nope. What about at -1? No. Do you notice there's kind of like a whole space in here between the 0 and the -2 that like no part of your graph is touching? There's like a break. So I start at negative infinity and I kind of come up to the -2, and then we've got a break. So I'm going to go to -2. Now, at the -2, do you notice that it's an open dot? So we're not touching it. But then you pick up again right here and you start touching the graph, and that's at 0. Now, on the 0, closed dot, we're going to use a bracket. And then from 0, we're touching the red, we're touching. We have an arrow. So we're going to go up to infinity. So this kind of says, okay, well, my range is the blue graph down here, and my range is also the red graph up here. And then if I want the whole thing, we connect them with a union, meaning all of those values are in the range. Last one, y equals, and then we have that function, and notice that this piecewise function actually consists of 3 different functions. So starting out, y equals 1. How do you graph y equals 1? Well, that's a constant function, and it's just a line at y equals 1. Just goes like that. Now, if we go and consider, that's only when x is less than -3. So -3 x value is right there. It's kind of like your barrier. And I encourage you to draw those on your graph. And it's when x is less than, so we're going to keep this, and we're going to get rid of anything over here. So we're going to erase this. Then I'm going to go and I'm going to say, okay, well, it says strictly less than. So open dot when I hit 3, because I don't want it to be equal to. Next one, x minus 1. This is y equals mx plus b, so -1 is my y-intercept, and then 1 over 1 is my slope, 1 over 1, 1 over 1, 1 over 1, and then I'm going to draw my line. And I already know something's going to happen, so I'm just going to kind of stop there once I hit the yellow. I could keep going, but I'm not going to. Because if I look at my barrier, this one exists between -3 and 3. So I've already got my -3 barrier. Now I'm going to draw my 3 barrier. And this is when x is greater than -3, but x is less than +3, which means I also have to get rid of anything in there. Open versus closed dot. This has an equal to. This has an equal to. So when I hit the barrier here, I'm going to be closed. When I hit the barrier here, I'm going to be closed. Third one, -2x plus 4. Y-intercept is 4. Slope, -2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So my line would go something like that. But this one is only going to exist when x is greater than 3, which means over here on the right-hand side of my graph. So now I have to erase anything I had in here up to my barrier. And then this one says greater than, which means open dot. And there's your function. This one actually has 3 pieces. Okay, domain, left to right. So if I start in the middle, I'm touching, I'm touching, I'm touching. If I get here, I'm still touching. I'm touching the red, touching the blue, so -infinity. If we go the other direction, touching the red, touching the red, touching the red, still touching, I'm touching the red. Now I hop over to touching the green, touch the green, so your domain, all real numbers, -infinity to infinity. Range, low to high. Okay, if I start here and I go low, I'm touching the red, touching the red, touching the red and green, touching the red and green, touching the green, 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 the whole way down to negative infinity. If I come back up, still touching, still touching, still touching, touching red, touching blue and red, touching red, will I be touching any part of the graph up here? And the answer is no, because this blue one, it has an arrow on it, but that's only out to the left. It doesn't go up. So your range goes the whole way down to negative infinity because that green part points down. But it only comes up to here, which has a dot, and that dot is at 2. So our range is going to be from negative infinity up to 2, and then that 2 has a closed dot, so we're going to put a bracket because we're actually touching.